Okay, guys, so there was another question from 3.2, number 12. Should be very similar to the last couple of problems that we just did. So number 12, again, our function capital G of x is given to be 5x squared minus 2x minus 3. And of course, we're going to do the same thing. We're going to look for the critical values, relative maximum minimum, inflection points, increasing, decreasing, concavity, and also ultimately graph. But of course, this is a quadratic function, so some of the stuff may not quite be there for this one. But either way, we have to go through the process. So always start with derivative, which is 10x minus 2. We're going to look for the critical values by setting derivative equals 0, solve for x. So move the negative 2 over. Divide by 10 to isolate x. And by the way, 2/10, which reduces to 1/5. Don't forget to always reduce. So now we have our critical value. So next step to go split the number line exactly there. And by the way, in calculus and mostly math, we like to leave everything in fraction form. So don't put decimal number 0.2. Leave everything in fraction form. I'm sure the back of the book always answers in fraction form. Okay, so leave the answer in fraction form. And then 1/5 to infinity. So we're going to do a test value. Now, by the way, to the left of 1/5, we can take our friend 0. 0 is there. As long as you can get a hold of 0, always use 0. So that's 10 times 0. So I'm just going to plug in 0 in place of x in your derivative function, which gives you, of course, negative 2, which is less than 0, which means your derivative is negative there, which also tells you the function is decreasing there. To the right of 1/5, we can take 1. 1, of course, is bigger than 1/5. So as you plug in 1 into our, again, derivative, 10 times 1 minus 2, which becomes 8, which is positive, which tells you your function is increasing there, okay? And by the way, because it's decreasing and then increasing, which basically means that it goes down and then it goes up, which means you're going to have a relative minimum there. That's the way I always like to do mine. When I see the sign of derivative, that kind of tells me whether it's max or minimum. So because it's going from decreasing to increasing, that's where you have your relative. If it was going from increasing to decreasing, it will be a relative max. Anyway, so we can already say the function is decreasing. Whatever derivative is negative, which is negative 1, negative infinity to 1/5. Also is increasing, where derivative is positive, which is on interval 1/5 to infinity. And we also have a relative minimum. And by the way, don't forget the relative minimum is going to come when you plug in the x value 1/5 into your original function. So I'm just going to write g. So don't plug it in derivative. You only do derivative for the when you're doing looking for relative maximum minimum. But to actually find the actual point, we always have to go to original function, plug in 1/5. And again, make sure you leave the answer in fraction form. So I'll let you plug in 1/5 in place of your x and do your little arithmetic there. So I think when you do that, you should get the order per 1/5 comma, I believe, negative 16/5, because I just worked it out myself. So make sure you double check that, make sure you agree, okay? So there's your relative minimum. So that's, and then by the way, don't forget in this case also, because we have a second degree function, I'll show you in just a second, of course, that there will be no inflection point, and this function will always be either concave up or down. In this case, I'm sure it's going to open up, so it'll be concave up, but either way, concavity and inflection point always come from second derivative. So to look for those, we're going to differentiate again, which by the way, in this case, derivative of 10x minus 2 is just 10, which is positive. So as you remember in the section, they tell you when the second derivative is positive, the function is always concave up. And you're not shocked by that because this is a problem opening upward, as I'm sure you remember from algebra, so I'm sure you're not shocked that the graph is going to be concave up. And by the way, because it never changes concavity from up to down or down to up, we can also say, concave up on the entire interval, negative infinity to infinity, which is pretty much everywhere. Also, no inflection point again, because no inflection points, because of course the concavity does not change, because it's always either concave up or if it was always concave down, last example, there will be no inflection point. So you already know what the graph looks like, but let's go ahead and take advantage of our relative minimum to quickly graph it. So here's pretty much the end of the story for this one. The last question is to graph, so I think I just erased my relative, in this case, of course, minimum. So I believe it was 1/5, comma, negative 16 over, so I'm just going to put negative 16 over 5 here. And of course, it was open up. And so there is the graph of your beloved problem. Okay, so there is your problem number 12, 3.2.